Hello, everyone. I wanted to go over 4 papers talking about how severe a disease Omicron can cause. There have been 2 papers that were published early out of South Africa, but those were a little bit more difficult to interpret in developed countries because the population in South Africa tends to have a younger population and also a population with high rates of natural immunity, as well as a population that has lower comorbidities that are more common in developed countries, such as obesity, diabetes, hypertension, those kinds of things. So I wanted to wait until we got some data from somewhere else where the comorbidities more closely track other developed countries before I made this video. But let's go over the South African data first. These first two papers were published 4 days before Christmas on December 21st. This one is looking at a seroepidemiological survey from October 22 to December 9th. So most of this data is pre-Omicron. But this last week or so represents Omicron, and they're using antigen tests. And we'll just go over some of the high-level results that they got, and then look at the one graph, which I think is the most interesting. So samples were obtained from 7,000 individuals, of which only 20% have received the vaccine. So vaccination rates in South Africa are relatively low, but they have a high seroprevalence rate. That means a lot of people actually got COVID. So when you test them for antibodies, a lot of them have antibodies. So you see overall seroprevalence range from about 56% in young kids to about 80% in individuals over 50 years old. In people that are vaccinated, of course, seropositivity is very high. You know, if vaccination should theoretically cause 100% seropositivity, but of course, testing is not perfect, and so they get 93%. In unvaccinated individuals, seropositivity is 68%. So that means in the unvaccinated population in South Africa, almost 70% of them already had the disease, either through Delta or Alpha or Beta, one or the other. Previous variants. So a large portion of the population has been exposed to the antigen either through vaccination or through previous infection. All right, so let's go look at the most important graph of this paper, which is this one. All right, so what you see here is this is a graph looking at this dotted line is cases, the blue line is hospitalizations, and then the black line is excess deaths. So deaths that cannot be accounted for in other ways that are more than the background deaths for that time period. And we assume that during a pandemic that excess deaths are due to the disease. And of course, the deaths lag the cases because, usually it takes about a week or two before people succumb to the disease. What you can see is that in the previous waves, the slope is not very steep. In this wave, the slope is very steep. This line is almost vertical. So that means it's very infectious. And in fact, this may be kind of a silver lining on a very infectious variant, is that it peaks out very quickly. When it is very infectious, it catches all the susceptible people very quickly, and then it comes down because it's found all the susceptible people very quickly. So it has a very steep climb and probably a steep decline. We'll continue to watch the data out of South Africa to see if this continues, but it looks like they've peaked out actually already on Omicron. And the important thing to note on this graph is that you see the hospitalization rates climbed pretty high. So you see that like in this, the hospitalizations are almost 50% of the case numbers, which probably means that their case numbers are grossly underreported. And that is usually the case in kind of a more resource poor area. And so these are probably underestimates. The hospitalizations are probably very accurate numbers because you can capture those. So it looks like 50% hospitalization in the previous wave, that does not mean that 50% of the cases result in hospitalization, because this is, again, this is probably grossly underreported. The actual number of cases are probably much higher than this, and the hospitalization rate is much lower than 50% if you take into account all the cases. However, you expect that testing will be similar across the waves, so that means relative to the number of cases that are reported, the hospitalization rate is quite a bit lower. So this looks like it's roughly 1/5, so probably 70% lower than the previous wave. So that was the first indication that the hospitalizations as a result of Omicron are much lower. Then this is the next paper out of South Africa, and it's early assessment of the clinical severity of SARS-CoV-2 Omicron variant in South Africa. The way they ran this study is they did a PCR test, and they separated between S gene target failure and S gene target capture. So what it means is that the old primers, the spike protein on the Omicron variant is so different that that some of the primers do not target the Omicron. So what they did is, if they have S gene target failure, then that means that's probably an Omicron individual, because it's not picking that up. All right, so the proportion of S gene target failure infections increased from 3% in October to 98% in early December. So 98%. So this is a proxy. They didn't fully sequence these things. They're just assuming that if the PCR test did not pick up this spike protein, then that must have been an Omicron case. And I'm guessing that they used other primers to pick up the nucleocapsid or some other to identify the infections. So anyway, it went up in prevalence from very little. And so not all of these S gene target failures are going to be Omicron. It's unlikely that 3% in October were Omicron. They may have been some other variant that wasn't picked up. And it's not like all 98% of these are Omicron. Probably the vast majority of them are, though. So anyway, they're using that as a proxy, which is, not as clean a data as sequencing it, but it's a reasonable way to run the study, and is a good proxy. And in science, we use a lot of proxy data. So they're going to use that. And what they found out is that individuals with the S gene target failure infection, so this, you can read this as Omicron infection, had lower odds of being admitted to a hospital compared to the other kind. So this is most likely Delta, with an adjusted odds ratio of 0.2. So the way you read an odds ratio is, if it's 1, it's the same. If it's higher, it's worse. If it's lower, it's better. So basically, the Omicron had an odds ratio of 0.2. That means it's 80%. So it has 20% of the hospital admissions as Delta did. 0.2, 20%. So it's 80% less likely to be hospitalized. So that's good information. So those are the two that were reported out of South Africa, showing that there's significantly lower hospitalization rate. So then now, more recently, there is a paper out of Scotland, I think this is University of Edinburgh. And what they did here is they did the same thing. They used a reverse transcriptase PCR test. And what they used S gene status as a surrogate for Delta and Omicron. S gene positive, so if it picks up the spike protein, then they assume that it's Delta. If it does not pick up the spike protein, they assume that it's Omicron, because the old primers were directed at the wild type. So Omicron was so different that it didn't pick it up. And what they found was that the odds ratio in theirs was 0.32. So odds ratio in here was 0.2. In here it's 0.32. So 32% were admitted. 32% were admitted compared to Delta. So about 68% less likely to be admitted to the hospital if you got Omicron. Then lastly, there's another paper out of the UK. This is the Modeling Center at Imperial College of London. And they found, overall, we find evidence of reduction in risk of hospitalization for Omicron relative to Delta. And they thought that it was about a 40 to 45% risk. reduction with Omicron. So, somewhere between 80% to 68% to about 45%. So significantly less. So about um, half the risk of being admitted with Omicron than with Delta. So taking the two, this and my previous video about the reproduction rate, which seems to indicate it's almost twice as infectious, but about half or a little bit better than half as likely to be admitted to the hospital. Looks like hospitalization rates, if we have the same amount, if we take into the reproduction number causing more infections, it may be a wash, and we'll have similar numbers of hospitalization in this wave as in last winter's wave, which was pretty bad actually. So I'm hoping that's not true, and the hospitalization rate is actually less, and hopefully the infections don't peak out at twice as high. The R number doesn't actually directly correlate with total numbers. It just correlates with the rate of increase. So the rate of increase has been very steep, and hopefully if we look at this, it will be a steep incline. Like, see, theirs did not peak out as high as the previous wave, although it was much steeper. And I'm hoping that is the case in the United States here as well, that it peaks out quickly, and that our hospitals don't get overwhelmed like they were last winter. All right, so I'll link all four of these papers in the description below. Please check them out for yourself, and thanks for watching.